Hello. Thank you for joining us for today's Caringo Tech Tuesday webinar. This session's topic is verifying content in Swarm Object Storage. I'm Sarah Cook, Director of Marketing at Caringo. For today's webinar, I'll be your host, and our subject matter expert is John Bell, Senior Consultant at Caringo. John will be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have several resources available via the Attachments and Links tab on your view screen. If you have any questions after the webinar, you can always reach us by email at info@caringo.com. So before we get into our presentation, we'll do a couple of introductions so you can know who is talking. So again, I'm Sarah. I joined the Caringo team at headquarters here in Austin, Texas in 2015, and I was lured by the Caringo technology, but also the opportunity to work closely with the engineering team. Prior to Caringo, I worked at Dell companies. John, would you introduce yourself, please?
Certainly. Thank you, Sarah. Again, this is John Bell, and I'm a senior consultant based in Austin, Texas. I've been with Caringo for coming on 8 years, and I specialize in the design, implementation, and management of object storage. And I've had the opportunity to work with many of our largest customers to transform their storage infrastructure with highly efficient and cost-effective object storage solutions.
Great. So I'd like to tell you just a little bit about Caringo for those of you who are joining us for the first time. Caringo was founded in 2005 to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth. Caringo's flagship product, Swarm, decouples data from applications and hardware, providing a foundation for continued data access and analysis while guaranteeing data integrity. Today, Caringo software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, Argonne National Lab, the UK Science and Technology Facilities Council's Scientific Computing Department, Texas Tech University, U.S. Department of Defense, the Brazilian Federal Court System, British Telecom, and hundreds more worldwide. And with that,
it's hard to get your
over to John.
When it's worldwide, it's hard to get your mouth around it, isn't it?
Yeah, just a little tongue-tied.
Yeah, very good. Well, thank you, Sarah, for the introduction. I greatly appreciate it. Let's walk through the agenda of what we're going to cover today as relates to verifying content integrity in Swarm Object Storage. First, we'll start off with a brief overview of what we mean by content integrity, just to set the stage for what we're going to be discussing. Then we'll walk through some methods as relates to using content MD5 hashes for verifying content integrity. We'll also go into a discussion around using integrity seals. Integrity seals are a proprietary method that is used in Caringo Swarm to verify the integrity of objects in storage. We'll provide a brief demo of the two in action, and then we'll segue into Lifepoint metadata headers to kind of tie all things together if you wanted to verify the integrity of the object and then lock everything down with worm-like behavior using Lifepoint metadata headers. And we'll wrap up with any Q&A that's left over as we go through the presentation. So just to kick things off, when we're talking about content integrity, what's the definition we're going by? You know, what's our approach? To us, content integrity is the accuracy and consistency or validity of content over its life cycle. You know, from the time it's created to it's written into storage, it's maintained. You know, it's protected by bit rot from the storage system itself, up to the point that it's deleted. So we want to make sure that we're maintaining the accuracy and consistency or validity of that content from the time it's created to the time it's deleted. So how do you address content integrity in Swarm storage? You need to address this at multiple levels, and you need to account for items such as, you know, human error and or human data tampering. any kind of transfer errors which may occur over the wire, any kind of integrity compromise that's related to system or hardware failures, things of that nature. It kind of runs the full spectrum, and this is just a sampling of all the things that you need to account for, but these are typically the three main areas of focus that we pay attention to when it comes to content integrity in object storage. So what are some best practices that you can employ to ensure that you have integrity of your content when it's placed into object storage? The three main practices are performing input validation, making sure that you have proper error detection and correction associated with data validation for data in transit, and then ultimately you're going to want to have some strong access policy and Lifepoint or life cycle constraints associated with the content that you store in the system. So let's talk about some of the methods that we can use to employ those best practices using the Content MD5 support in Swarm. Now, Content MD5 header support is typically used to detect errors that are related to data in transition or on write. And this is typically client initiated, although it can also be set up as a global server configuration so that Swarm will always generate the content MD5. We'll talk about that here in a bit, but typically it's provided by the client. The client provided content MD5 header is given with a write request, be it put or post, with a base 64 encoded MD5 sum as the value that you're going to be populating in that content MD5 header. You can also have that
question.
Sure, go ahead.
Why does the content MD5 header have to contain base 64 encoding values?
Oh, that's a very good question. So what we're trying to do here at Caringo, some of you may have been with us when we went over our SDK implementation and API access and things of that nature. And what we tried to do with the Swarm API, which we call Simple Content Storage Protocol, or SCSP, is adhere to HTTP 1.1 requirements and all the associated internet RFCs that go with that. So long story short, the population with base 64 encoding of the 128-bit MD5 sum of the content is specified in RFC 1846. So if you really want to dig down into the details as to why that header has to store a base 64 encoded MD5 sum, it's outlined in that RFC, and that's what we try to adhere to. So Swarm as a product tries to adhere to internet standards wherever possible, so that you have full open access to the objects that are stored in the system. And hopefully that addresses their question.
I think so.
Okay. So anyway, yeah, there's a client-provided content MD5 header with base 64 encoded MD5 sum. You can either give that, there's a deprecated way where you provide the header directly. You can also have this generated automatically using a request query arg that's called gen content MD5. It's a client query argument that you can issue to Swarm saying, I want you to generate this and check this and make sure that everything went over the wire the way it was supposed to, and return an error for whatever reason if it didn't. You can also tell Swarm to do this every time with a global cluster configuration parameter, which is called SCSP.AutoContentMD5 computation. This is something that you would set in the cluster.cfg file, or the cluster configuration file for Swarm, and every write request that comes in is going to generate and create this content MD5 header and its associated value for the content that's being stored within the object. Okay, so some examples of what this may look like. An example header for content MD5 would look like this, where you have the key and value. You have content MD5, and then you have the base 64 encoding of the data that's stored in that object of its MD5 sum. And that's what it would look like. And if you want to have an idea of how that can be generated, here's an example of how you can generate a base64 encoding of a file. So we have a file there under the demo directly called test.txt, and we want to get its MD5 sum, but we want base64 encoding values. So you can just use a simple OpenSSL pipe to do that. You generate the binary output of an MD5 digest, and then you pipe that to OpenSSL again to encode it in base64 format, and that gives you the output that you see above for the value of the content MD5 header. And we'll show this a little bit in the demo. You'll get a feel for how this works. Okay. So let's talk a little bit about integrity seals. Integrity seals, again, that is a proprietary method that Swarm offers to developers that allows you to basically, ensure the validity or the integrity of the object as a whole in this case. So what is an integrity seal? An integrity seal is a URL that contains the object name or UUID and the type of hash algorithm that was used for the computation. So in this case, you're not constrained to just MD5, and we'll go over that in a little bit. You can use other hashes as well. We'll show you which hashes we support. And again, an integrity seal can be requested on client write using the hashtag query argument. And a success for that results in a HTTP 201 response, and that's going to include a location header with URL that can be used to retrieve the data. Not only that, that location header can be used if you want to turn around and change the integrity seal to a different encoding method on the fly in future. So let's talk about that a little bit. So the supported hash types we have for integrity seals include MD5, SHA-1, SHA-256, 384, and 512. Those are the ones that we support currently. And again, as I mentioned, the hashes for these integrity seals can be upgraded in place. So let's say, for example, you initially created an object and gave the hashtag query arg with MD5. You could go back later and perform a get on that object using the hash and the new hash type query args, and then the new hash type query arg, you would say what hash type you'd want to change it to. So you could say new hash type equals SHA-256, for example, and it would change it from MD5 to SHA-256. And we'll show you what that works when we do a quick demo for it as well.
John, what does MD stand for, and what does SHA stand for?
MD is message digest, and SHA is secure hash algorithm. So those of you in the audience that are familiar with the cryptography side of things and hashing and how that works, those would be acronyms that are familiar to you. But for those of you that aren't, that's what they mean. MD is message digest, SHA, secure hash algorithm.
Thank you.
Mm-hmm. Okay, so that said, let's go ahead and dive into a demo real quick. And we'll start off with the simple stuff first. We'll do a couple of quick demos with content MD5. Then we'll show you how the integrity seals and the hashing works there. So let me do my screen share here, Sarah.
I always love these demos. It gives me such a better understanding of our product.
Okay, let's do a screen share. Right, and let me know if you see this, Sarah. Sometimes we have to wrestle with this a little bit.
It's always a bit tricky.
It is. Okay. And let's start with this one here. And Kate, can you see that okay?
I can.
Okay, very good. All right, let me go ahead and. So what I'm demonstrating here, this is the login to Swarm's content portal. And what's happening in the background is you're interacting with our content gateway. But this is the content portal where you can, create and manage and delete data that you want to store in Swarm Object Storage through the UI. So let's go ahead and log in real quick. And as you can see here, we have our dashboard. And let me pop into my demo bucket. And what I'm going to do is I'm going to demonstrate an upload of data. And what our implementation of Content Portal and Gateway does, it will automatically generate for you a content MD5 of the data that's in the object that was created when you store this file in the system. So let me go ahead and do that. And I'll show you what happens. Okay. I like my snowman pics. Let's go ahead and upload that.
Well,
and
when
upload
you're
is
in Texas in September, the idea of snow seems very attractive.
It really is, especially after the summer we've had. Okay, so we have an upload of a file. In this case, it's a picture. It doesn't show the thumbnail because it's quite large, but that's okay. The key here is we want to go down and look at the header information, and you'll notice right here that content MD5 header was created for us when we posted this object to the system. So in the case of Gateway, it does that for you automatically. It makes that call for you automatically and says, I want to have this created, so that you could basically check for you could run that OpenSSL encoding like I did, like I showed in the slide, and you could look at the original content on the client side. And what you should see is that these content MD5 values would match up, is what that would amount to. Now, I'm not going to go through the trouble of doing that here because we'll be able to see that when I do the command line piece of this demo. But that's the way you would verify that, is you could run the base 64 encoding of the MD5 sum of this original file off the system. And what you should see to verify that everything is okay is that those two would match up. That's how you would go about verifying that, transfer over the wire was successful. They have the same base 64 MD5 sums.
Right. And if it was unsuccessful, you would see two lines that did not match?
You would basically see an error return back saying that for some reason there was an error in transfer. It would pop up as an error window in Gateway, basically saying that something happened in transfer. If you did not get that 201 code back, then the portal would complain and show a trace back for the error, is what would happen.
Right.
Yeah. Very good. That's pretty straightforward. Let's go ahead and stop sharing that. And let me know if that goes back to the original slides, Sarah.
It sure did.
Okay. And let's take a look at this from what it looks like from a more command line perspective. You can kind of see the guts of what's going on there when you do this. Bear with me here for just a second. Well, who doesn't
want to see the guts?
Well, some people like to see how sausage is made, and this is their chance. Okay, screen share. Let me do this again. There we go. Sorry, I had to wrestle with that for a little bit.
No problem.
And let me know if you can see that, Sarah.
It is making the transition, and there it is.
Okay, outstanding. Okay, so for those in the audience, what we have here is we have a group of test files that you see up here. And what I've done is I've basically generated base 64 encoding of the MD5 sum for these test files. And I've listed that out here. This is what their base 64 MD5 sums look like. And then here's an example of how you would generate that. And as you can see, those two are the same. If I wanted to do something similar for the test2 file, it would just be against test2. And as you can see, those are the same there. Right. So basically what we want to do is when we're transferring these files is we want to make sure that they go over the wire successfully. I'm going to be talking to Swarm directly in the case of this demonstration, and I'm going to be mocking this up with curl, so bear with me. So let's go ahead and put this test1 file into the system. What I'm doing here is I'm posting new data, and I'm making sure that curl can follow the bidding process that takes place in Swarm when I do this. That's what the post 301 and location trusted does, is follow the bidding process. And then we're doing a post. Oops. Okay, and then we're going to be putting in, binary transfer of the test1 file. And what I want to do is I want to make sure that we bin content MD5 on this when we put it into the system. So let's talk to one of the form nodes. And we're going to put this into a bucket. And we're going to put it in the test domain. Bear with me here. Gotta get my args right. This is why the UI makes your life so easy. It takes care of all of this stuff for you. And we're going to tell it gen content in MD5. Just like that. Okay. Let me make sure my syntax is correct. That should do the trick. Oh yes, of course I have to give it the name. I knew I was forgetting something. Like so. Okay. And when we put it in there, we'll call it, the named object will be test1.txt as well. So let's go ahead and do that. And as you can see, we have a 201 success. Basically what that means is that we generated that content MD5 and Swarm checked it, and we made sure that this transferred over the wire correctly. And then Swarm turned around and stored that content MD5 sum as a content MD5 header in base64 format as associated with the object. And that's what you see here in that header information for the object. And you will notice that is the same as what we have here. We know that that went over the wire, and the content itself within the object maintained its integrity as it was transferred into the system. Just a nice little simple trick, to verify that that things transferred over the wire the way they were supposed to. And like I mentioned previously, you can set up your integrations to do this automatically, either using this gen content MD5 argument. You can set up the cluster itself to do this every time, and it will always create this content MD5 header, and so on. And you'll be able to go back and check that over time. And let's say for whatever reason, somebody edited test.1. So let's go ahead and make a change, like so. And then we run our MD5 sum base64 on it, and we get that value. Okay. And we come back later and we want to take a look at the MD5 sum for that object. So let's go ahead and do a curl. And we're just getting better information off the object. Like so. Okay. And we see, we can tell that, what's on the client is different from what was stored in the system. So it's kind of a simple way to go back and say, is this really what we stored in the system? And in this case, the answer would be no, that what's on the client has changed over time versus what was stored in the system, because these are different. It's kind of ugly to see it behind the curtain, but if you're into developing these integrations and you're mocking things up to take advantage of these content integrity techniques, this is kind of the way you would go about doing it. And you'll notice we're just interacting with the storage using standard HTTP 1.1 with the associated query args that we support to get this done. So it's actually quite simple to do. And, translating this into a language such as Python or so on would be very easy to do.
For those who know Python.
For those who know Python. I don't know Python personally, but I've heard about it.
Me too.
Okay. So now that we've done an example with content MD5, let's do an example with unnamed objects, and let's do it with an integrity seal. And we're going to do the hash query arg in order to do that. So let's go ahead and do that. This one's a little bit harder for me to mock up, so bear with me. We'll use the test2 file for this. Here. I believe I have that right. Just making sure. Oh, yeah, I knew I did something wrong there. Bear with me here for just a second, Sarah. Sometimes I need to check my own information. Very good.
Don't we all?
Yeah, I know. I just bear with me here for just a second. Yeah, I always get that wrong. I fat finger it. Okay. And can you see the screen now?
I can. I spend many days wondering what we did before we had Google and could just search for any answer we needed.
Right. Let's do it with history real quick. Okay, very good. Now what we did here is we used the default hash of MD5 with this hashtag argument. And what we have here are two location headers. Because of replicate on write, we're going to have two objects created automatically. That's why we have two location headers. But we only need one to do the work. Okay, so we have the location here and here. That did not give me what I was looking for. Bear with me here for just a second, Sarah. What did I do wrong there? Yeah, let's do it on hash test. Oh yeah, I have to give it.
Supposed to be the same?
No, I have to give it the argument. I always forget that too. And for those in the audience, I apologize. This is something that I don't deal with every day. So I just kind of got into a little bit of a brain freeze here, switching from MD5 to integrity seal. So I apologize for that. Anyway, let me show you what this looks like.
That leads to an interesting question. As a storage administrator, how often would you be doing this? Is this something that you need to do on a regular basis? Or
as an operator, as an operator, you would not be doing this every day. This is something that's of more interest to a person who's doing a integration with Swarm, and if they've made the decision whether or not they're going to go with, the content MD5 technique, whether or not, they're going to use integrity seals, things of that nature. And really it boils down to a decision during the project requirements and associated implementation phase as to which way you would go with these techniques. And I confess, the technique that I'm showing here is not one that we encounter frequently in the field. The vast majority of the implementations that we've rolled out in the field are using the content MD5 header technique.
And is this something that an auditor might use?
I'm sorry, say that again?
Is this something that an auditor might use if they were auditing the data?
Right. I mean, this is what comes into play. What you're demonstrating here with an integrity seal is not just the integrity via content, but the integrity of the entire object. And then what you can do is you can change these hashes over time depending on the cryptographic requirements that are needed for the integrity of the hash. Let's say an auditor comes back and says, MD5 is not good enough. I need you to use a stronger hash to demonstrate the integrity of this object. Well, then you could go back and change on the fly from MD5 to, say, SHA-256. Maybe that's their requirement. And instead of having to rewrite the data, you would just recalculate the hash using the associated query args and a get verb in HTTP or the SCSP equivalent to make that change. Hopefully that makes sense.
It just makes me glad that I used to be a technical writer.
Let's go ahead and do this now that I've actually figured out how to do it. Okay, so there we go. We have a new stream created, and this is what we want to see. We want to see location headers created that have the UUID for the object, the domain it lives in, but more importantly, what hash type was used and the actual value of the hash itself. So I'm going to save this because I'm going to need this for reference when I do the next step and I actually change the hash. You go ahead and save that so I don't lose it. All right, very good.
So you're going to change the hash on the fly.
Right. Let's say an auditor. Right. Let's say an auditor comes to me and says, MD5 isn't good enough for use of integrity seals in your implementation. You need to go back and change these integrity seals to use SHA-256. Right? So let's go ahead and do that. I may actually have this in a history.
And is SHA-256 a more stringent requirement?
Right. It's a more powerful hash that we're. Go ahead. I think I had this in my history, so bear with me here. Right. And this is where we're going to do it. We're going to change that new hash type to SHA-256. So let me go ahead and put in the location header information of interest. Okay. And I use that location header that was returned back to me, as you see up here. And then the arguments of note here is new hash type. And we're going to change it from current hash type of MD5 to a new hash type of SHA-256. Now the key to watch out for here is that we need to look at the raw output, this request, in order to get the new location header that we need to save if we needed to go back and change the hash algorithm again for this integrity seal. And that's why I'm using the arguments that I'm using here for this request. So let's go ahead and do this. Oops, I forgot my opening quote. single quote. Bear with me here.
Details, details.
Well, this is how development works, as you mock things up. So let's do this again. There we go. Okay. So what I've done here is I've gotten the raw output back, and that raw output has given me the new location in header information. And you will notice that this hash is much larger now, and that the hash type is SHA-256, which is what you would expect, because it's a base 64 encoding of the 256-bit SHA algorithm output. So it's going to be a longer base 64 encoding representation. And if you needed to grab that later, you would want to save this information, of course. So we would just go ahead and do that. We could grab all of this.
Copy and paste is our friend.
That's right. And then, you can see what it was before and after, if that was a concern to you. And typically this gets saved, somewhere in an integration. They would save this in a tracking database or something like that if they needed to go back and look at it later. I'm just showing you in a very basic way how you would mock that up with curl, so you would know the type of information you would need to get back, what kind of interaction on output you would need to account for the integrity seal and so on. But that demonstrates that we didn't have to rewrite the data. We issued a get, we told it to use a new hash type, and we gave it the original hash type. Now there's something to watch out for here with integrity seals. If for some reason you gave it its original hash and that value was incorrect, it would not make the change, and it would pop you out with an error, and it wouldn't even return back the contents of the file, because it would consider that to be, that's a bad hash, this is a bad request. You don't know what the hash is. You're not allowed to make these kind of modifications on the content. So it's a pretty good protection mechanism. You just have to account for those type of things if you're doing a native integration like this. And that's pretty much all I had for demo. So I'll go ahead and hide that. Okay, very good. And we should be back to slides, Sarah.
And there we are.
Okay, excellent. So we've talked about content MD5 checksums and integrity seals. Really, to wrap things up and to lock things down, I wanted to dive in a little bit and talk about Lifepoint metadata headers, specifically as related to creating worm capability within Swarm. What do Lifepoint metadata headers do, first of all? They specify a constraint that's associated with an object in Swarm. For example, that could be the number of replicas that are stored. It could be the erasure coding scheme that it's using, if it's stored using erasure coding instead of replicas, and so on. And these constraints are evaluated by Swarm's health processor to determine, what is healthy for the object at a point in time in its life cycle. And if you look at this from a content integrity perspective, the constraint of interest to us is going to tell the health processor whether or not the object should be deleted at a specific point in time, or even even if it could be deleted at all. And this is done with the deletable and delete directives in the Lifepoint headers. And typically what you're going to see is deletable equals no is going to be applied to implement worm behavior in Swarm storage. So let's take a look at what that would look like in an actual header that would be stored in an object. So a Lifepoint example, that would emulate that worm behavior or implement that worm behavior would look something like this. In this first Lifepoint, what we're saying is that up to this date and time, Wednesday, December 12, 2015, etc., we want this object stored with 3 copies, reps equals 3, in the cluster, and we don't want it to be deletable. So basically, any verb that comes in with API that says, I want you to delete this object, it's not going to allow that to happen. It's not going to delete the object. So once you've written it and you've confirmed that the contents that you want in there are in there, you can furthermore set a life point saying deletable equals no, and that'll freeze it in place, and it won't be changeable within the system. Now, this next life point header associated with the object says that after this time, but before Sunday, June 8th, etc., I want you to change it from being non-deletable to only keeping 2 copies in the system and allow for it to be deleted by a client request. And then finally, after this date has expired, the next time the health processor comes by and evaluates the constraint in the LifePoint header for the object, it's going to see that it can be automatically deleted. So what happens here is that after this date, the next time the HP does an evaluation on this object, it's going to see that this content can be automatically deleted by Swarm itself. And it'll execute that action. And at that point in time, the life cycle of the object is ended and it's deleted from storage. Pretty straightforward example of how that would work for a simple life cycle for an object.
Yes.
All right. So let's summarize what we've gone through here today. What we've demonstrated is that Swarm does provide several mechanisms to confirm and maintain the integrity of the content stored in objects within Swarm storage. But one thing we do want to call out here, it's important to also make sure that the client itself is trusted, that its integrity is good. And a simple example of that is memory errors can happen. And error correction code, especially ECC memory, can be your friend on the client. Sarah, we actually had a support ticket come in, I want to say a couple of years ago, where a customer was attempting to use the content MD5 method for verifying the integrity of what was being stored in Swarm versus the original that was on their system. And they kept coming up with a mismatch when they issued that request from that particular client. And they opened a ticket with us saying, we can't get these MD5 sums to match up. I'm absolutely sure I'm generating the MD5 sum correctly. What's going on here? Well, it turned out what was happening is that when they issued that request from a completely different machine, they got the same value they were supposed to get as calculated by Swarm and Swarm storage. And what happened is that they had memory errors on the original client. They had bad memory on that system. And as a result, the hash that was being generated by the MD5 utility on the client was a bad hash. So it's really important end to end when you're implementing talking to object storage or any storage for that matter, make sure that you trust the integrity of the clients as well, and that they're actually generating something that makes sense. Because at the end of the day, it's garbage in, garbage out, as we demonstrate there. Swarm will take what you give to it, but if you're just giving it something that doesn't make any sense, it'll happily go ahead and store something that doesn't make any sense. It's up to you to make sure that what you're putting in the system is actually what you intended to put there. And fortunately, we provide mechanisms for you to perform that task.
Right, and as we wind down, we've got one more question. Are there situations where certain content check approaches work better than others?
Yeah, there are. If you have plans on doing, let's say you plan on having multi-protocol support using our Swarm Gateway, for example, and you want to be able to take in requests coming in either by our native protocol or written by S3, then the best way to go would be using the content MD5 methods that we demonstrated today, because they can be done automatically by the content gateway and by the content portal that interacts with it. And our S3 API implementation also makes sure that type of information gets instantiated with the object when it's created, and it uses that method. And we call that out in our documentation along with any slight differences that are associated with it. But ultimately, if you're taking things in from multiple protocol requests, we would recommend using the content MD5 approach. Now, if you're not interested in that and you're building what amounts to a and you know that you need to have the capability further down the line to demonstrate, say to an auditor that I'm using a really strong hash to demonstrate the integrity of this object over time. and that its content hasn't been tampered with. The direct integration approaches, they can use content MD5, but if you know that you may need to change those hashes in the future, you want to use integrity seals, because it provides you with that capability to make the change of that hash without having to reload the data into the system. Kind of a simple pro and con there for which approaches you would take. Most people go with content MD5.
Great. So thank you, John, and thank you everyone for joining us today. To keep up with Caringo, you can follow us on Twitter, LinkedIn, or Facebook. You can also subscribe to our monthly email newsletter on caringo.com. If you have additional questions or you would like to schedule a custom demo, please email us at info@caringo.com. And I'd like to also invite you to join us for our next Tech Tuesday. That will be on October 22nd, and our topic will be Swarm Object Storage Solutions for High-Performance Computing. So with that, John and I will say goodbye, and thank you again.
Yes, thank you, everyone. Goodbye.